Today's lesson is 3.3 proofs about angle pairs. Let me go ahead and fix that. It should be 3.3. All right. In this lesson, we are going to go ahead and prove that two lines are in fact parallel or that two angles are in fact congruent. Before we do that, let's go ahead and take a look at a proof. In example 1, they want us to complete the following proof. I just want to show you some of the pieces of a proof. So a proof will have a given statement and a prove statement. You have to come up with the statements that go in between these two. Now you always start here with a given. So with the first thing I'm going to do is I'm going to make a chart, a table where I have the statements on the left side and the reasons on the right. And I've already gone ahead and set this one up for us so that we know that there are 6 statements and 6 reasons. Every statement that we make must have a reason to go with it. Let's go ahead and get started. So remember, the given is where you start. So you're simply going to take your given statement and you're going to place it over here in the statement side. You copy it. Its reason is that it was given to you to prove. Now, one thing I would like you to know is that you always, every time you do a proof, you start with the given or the givens sometimes, but you always start here. Always, always, always. All right, now since this problem is an equation that we need to solve, we're just going to go through and we're going to solve it. So the first thing I would do is, let me grab this lighter one, is I would distribute the 2 to the x and to the 4. Actually, you know what? Let me change this one to black. So that would give me 2x plus 8 is equal to 12. And what I said that I would do is my reason. So my reason is distribute, or the distributive property. But I'm just going to keep it to distribute because I don't have the space. But it is technically the distributive property. Now I'm going to look at this equation and I'm going to say to myself, what would I do to get the x alone? Well, the first thing I have to get rid of is my plus 8, and I'm going to do that by subtracting 8. So I'm going to subtract 8 from both sides. And I could show it like this. This is the subtraction property. When I subtract from both sides at the same time, notice I added this to both sides. This is the operations property. Add, subtract, multiply, or divide. When I do it to both sides, that is the operations property. Now watch what I'm going to do in the next one. In the next one, I'm going to say, well, the 8 minus 8 would be 0 and give me 2x. And 12 minus 8 would be 4. I've actually gone ahead and done the subtraction in this step. This is not the subtraction property. This is actually doing the operation, which we call simplify. Okay, so be careful. The difference between the operation and simplify is when it's the operation, subtraction or addition or multiplication or division, you are going to see that operation written on both sides of the equation. When we actually do the operation, when we actually subtract, that is when I use simplify. All right, so now I'm thinking in my head, what would I do next? Well, I would get rid of the 2 by dividing by 2. So I could write it like this. Once again, you guessed it, this is the division property because I'm showing the division on both sides of my equal sign. Lastly, I would actually go ahead and do the division, which would give me x equals 2, which is simplify, because I've actually done the operation. Now, you might have been thinking, Miss, why did you use given for the first reason, but you used simplify and not prove? Well, that's because is not a reason. That's like saying, well, that's what it is, because I said so. Okay. Prove is something that you need to back up. So prove isn't just something that I want you to do. It is not a reason. So I would like you to add right here, and this one's pretty important. You never, ever, ever use prove or solve or answer or solution as a reason. Never, ever, ever. That's like saying, well, it is because it is. Okay. You use the word simplify. That shows me that you did an operation. You're technically simplifying the division. Okay. All right, let's go ahead and take a look at some of the properties that we are going to use when we move forward to do our angle pair proofs. So there are three properties: the reflexive, the symmetric, and the transitive properties. Let's go ahead and go through these properties. Now, the reflexive property works for both sides and for angles. Today, we're going to use them for angles, but we can in the future, and we will in the future, use them for sides. So basically, the reflexive property says I am equal to myself. So my side AB is equal to my side AB. For my angle pairs, it says the measure of angle A is equal to the measure of angle A. Basically, duh, I'm equal to myself. Okay. The reflexive property doesn't get used too much, but it does get used from time to time. All right, let's go ahead and do the symmetric property. Now, the symmetric property can be quite helpful. Normally, we want to use the symmetric property if we're going to do some substitution. That's where it comes in handy if we need to rearrange some stuff so that it makes it easier for us to see. It basically says if side AB is equal to side CD, then side CD is equal to side AB. Do you see what I did there? Let's see if you can catch what this property is all about when I do it for angles. If the measure of angle A is equal to the measure of angle B, then the symmetric property says the measure of angle B is equal to the measure of angle A. What this one does is it switches around the order. We started with A equal to B, then we switched it to B equal to A. They just switched spots. That's all they did. This is the symmetric property. It comes in useful from time to time, but the last one is the one that is the most useful, the transitive property. Let me go ahead and grab my blue. This one is very, very popular, and you're going to use this one quite a bit. All right, here we go. If side AB is equal to side CD and side CD is equal to side EF, then side AB has to be equal to side EF. Notice what's happening here. What am I doing? There we go. Both AB and EF were equal to CD. So the thing that they shared in common was their equalness to CD. So basically, I could take that out and say, well, if I am equal to CD and you are equal to CD, then we must be equal to each other. That's what the transitive property does. It works for angles as well. If the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then the measure of angle A has to be also equal to the measure of angle C. There we go. Okay. Basically, what I'm doing is seeing that two things are equal to the same thing, which means they have to be equal to each other. I like pizza. Do you like pizza? If you said yes, then we are equal to each other. All right, let's go ahead and take a look at our first example. Now, in these examples, oops, there we go. In these examples, these three examples that we're going to do are very similar to the examples that you're going to see in your assignment today and on your test. The first three that you're going to see today the first two that you're going to see in the notes today are going to be like the one on the test. The last one, you are going to see that in your assignment. So please make sure you pay special attention to the last one because that one's going to be the last question in your assignment today. All right, here we go. We are given that line X and line Y are parallel to one another. So notice in the picture there are no marks. We are told that they are parallel. We need to prove that angle 5 is congruent to angle 4. All right, here we go. So let's take a good look at our picture. Some of the things to do are to go ahead and mark what is given to you. It's a very good habit to get into, especially when you are doing a proof. So we're going to copy down the statement because remember, we always start with the given statement and its reason is always given. Always, always, always. Once we do that, we want to make sure that we mark the picture. Okay, this helps our brain when we're doing the problem. All right, there's only one other statement, so it has to do with the proof. It automatically it has to. So what I'm going to do is I'm going to grab my highlighter and I'm going to highlight the two angles that they had given me that are put in the proof. So 5 and 4. I'm going to look at these two angles and I'm going to look at my sheet, my foldable from 3.1 and 3.2, and I'm going to say, what kind of angles are these? Well, I could start by saying, are they interior or are they exterior? Remember, the interior angles would be between the two lines, so this would be considered interior. Ooh, I got the big one on. There we go. And then the other ones, I think I used blue, would be considered the exterior. The ones outside would be considered exterior. So there we go. So I have two interior angles. Wonderful. Then I would ask myself, what are they doing? Are they on the same side of this transversal or are they alternating across it? Well, they're alternating across. Did you see how they flipped over the line? If they were on the same side, it would be highlighted right down here and we'd slide right along the transversal. So I'm going to say angle 5 is congruent to angle 4 because if the lines are parallel, then what kind of angles are these? What kind of angles are these? Well, they are alternate interior angles and they are congruent. And that's it. We're done. This proof is done. All right, let's go ahead and take a look at another one because yes, it is that easy. Now be careful. You need to be careful about which part comes first because in your assignment, these two parts can switch. How do I know which one goes first and which one goes second? Watch your given. Notice my given says parallel, so my first has to say parallel as well. If my given did not say, if my given said congruent, then I would switch them, okay? And we're going to see that on the next example. All right, my given says that angle 1 and angle 8 and angle 1 are congruent, and I have to prove that they are parallel. I cannot mark the picture yet. So I cannot come over here and mark it in the same way that we did the last one. That's not the marking that I want to do. The marking I want to do is that angle 8 is congruent to angle 1. I want to always mark the given. So I find angle 8, I find angle 1, and I mark them. I'm never going to mark something. I'm never going to mark a proof. I'm never going to mark a proof until I've completed my proof. All right, let's grab our highlighters. Angle 8, angle 1, interior. Remember, you always want to know, where are your interiors? Where are your exteriors? Because that's what you need to do. What kind of angles are these? Well, they are exterior. Notice that they're both in that blue section outside of line A and B. So I'm going to go ahead and I'm going to look. Are they on the same side of the transversal or are they on the opposite sides? Well, one's here and 8's over here. They flipped across, so these are alternates. I'm going to go ahead and say angle side line A is parallel to line B because if, now notice, I'm going to take the one from above and I'm going to flip it because notice that my given has congruent. So that means the congruence must be here, then we can be parallel. So I'm going to say if, I'm going to say the type of angles that they are. Okay, so I'm going to say the type of angles that 8 and 1 are. And this is because, take a look, my given is congruent, so my first statement must say congruent. It always has to look that way. You have to have it before the comma. Let me go back to the other one and show you once we finish. Then the lines are parallel. Okay, so watch, 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 watch. Congruence, congruence first. Parallel, parallel second. 1, 2. It's like the proof is telling you exactly which one to pick. Look at the one we just did before. 1, parallel, 1, parallel, 2, congruence. First, parallel, then second, congruent. So it's doing it exactly how you should do it. The only thing you've got to figure out is what kind of angles 5 and 4 are. What kind of angles 8 and 1 are. Okay? Oh, I missed the angle symbol. There we go. There we go. All right, so those are our two easy proofs where we just have to recognize what kind of angles we have, and we have to know when to use what, okay? The last proof that you're going to have is going to be a little bit more complicated one like this. It is going to contain 1, 2, 3 lines cut by a transversal. It will contain 8 8 angles, and it will give you 2 givens, okay? When you have 2 givens, the most common thing to do is to make them statements 1 and 2. So we're going to go ahead and start with y is parallel to z, and this is given. And I could actually go ahead and mark that as well. Then I'm going to do my second given that angle 4 is in fact congruent to angle 8, and this is given. Just because you use it once, a reason, doesn't mean you can't use it again. So we could have a proof where Everything is talking about alternate interior angles or alternate exterior or corresponding or same sides. It doesn't matter. Um, you can repeat reasons, especially givens. If there's two, then there needs to be two given reasons as well. All right, let's go ahead. We marked the first one. Let's mark the second one. 4 and 8. And I'm going to grab my highlighters. All right, now I don't want to go quite into what kind of angles 4 and 8 are right now. What I want to do is I want to use the angle 4 or 8 that goes with the first proof. So my first proof, remember, were these parallel marks right here. Which one of these angles is on one of these two lines? So which angle is on line Y or Z? 8 or 4? Well, 4. 4 is right here on line Y. So I want to use angle 4. I want to say that angle 4 is congruent to which angle in line Z? Not to X, to Z. Okay, which angle in Z is angle 4 equal to? Well, there's only two of them. Is it equal to 2 or is it equal to 1? Which one is it equal to? This one or this one? Well, if you remember, these would be considered interior angles. So let's grab our marker. These are our interior. These would be considered interior. And exterior would be out here and out here. Okay, so be careful. Those are exterior angles. Everything else is interior. Okay, so if this is the hold on. There we go. If this is my transversal, these two are on the same side, which means they're supplementary. So it would have to be angle 1. Those would be my alternates. Okay, so why are they congruent? If the lines are parallel, then alternate interior angles are congruent, okay? This one's a little tricky because we kind of have to pretend that this given wasn't here. So here's number 1, here's number 2, here's number 1, here's number 2. That one was tricky because statement 2 was another given. All right, now here comes the tricky part. What we're going to use here are these two statements. And what we're looking for is something that has been repeated. We purposely picked angles from lines Y and Z so that we would get a repeat. So who is being repeated? You have angle 4, angle 8, or angle 1. Those are the only numbers I see. Which one is being repeated? Well, you guessed it, angle 4. If angle 8 and angle 1 are both equal to angle 4, then per the transitive property, they must be equal to each other. So I'm going to say that angle 8 is congruent to angle 1 by the transitive property. Just a hint, you will be using this when you do the proof in the assignment today. The fourth or fifth, just depending on how many statements it has, is going to be the transitive property. Now I can go ahead, there we go, and I can look at angle 8 and angle 1. So let's go ahead and look at angle 1. Let's add it in here. Oh, let's grab it in purple. We're going to look at it, compare it to angle 8. What kind of angles are these? We know that they are equal. We've just said that they are. What kind of angles are they? Well, they're both interior. Are they on the same side or do they alternate? Well, they alternate, right? 1 jumps up to 8. So I can say that that line X is congruent to line Z because if my alternate interior angles are congruent, then my lines are parallel. Okay? Notice once again, the statement says parallel. The last part of the reason, the second part, has to also say parallel. Good luck on that one, guys. Do the very best you can. And if you have any questions, please feel free to ask.